trying to put all of these very diverse agents, for example, collective tissues navigating morphospace, together with conventional agents on the same scale, is that you can come up with a central invariant, which I have picked as the spatiotemporal size of the largest goal you can pursue. So all agents have in common one fundamental thing, which is that they pursue goals. And so now the question is, are you only interested in the local sugar concentration and you have a memory of a couple of minutes back and a predictive capacity of a couple of minutes forward, and then you might be a bacterium? Or do you have a bigger cognitive light cone and you might have a memory going backwards and some predictive capacity going forwards, but you're never going to care about what happens in 3 months, 2 towns over. So you might be a dog if that's the case. Or you might be a human, which has a huge cognitive light cone, and you're actively working towards world peace and what the financial markets are going to do 100 years from now. You could have a huge cognitive light cone. So this idea of, and we, of course, are a compound intelligence where our cells have little tiny light cones and our organs do, and so do we, and possibly larger structures in which we participate. So this idea of a cognitive light cone is based around the goals that any particular system can follow. And so that allows you to start thinking about what an individual actually is. What are cells? Given that we're all collective intelligences, we're made of parts. We're basically a bunch of cells in a trench coat. How does the collectivity and the unification happen? Well, let's look at the very early steps of embryogenesis. This is an embryonic blastoderm. There might be 50,000 cells here. And we look at that and we say, there's one embryo. What do we mean by one embryo? What are we counting? What is there one of? Well, what there's one of is alignment, not just physical alignment, although that's true too. Cells have to physically align with each other in planar polarity. But we are counting alignment of purpose. What we're saying is that under normal circumstances, all of these cells will work together to build exactly this thing. This whole blastoderm, all of them together have this one goal. And we know that because if we try to deviate, they will try to compensate. They are all together trying to get to this one goal. We're counting goals and alignment, and they have a particular size of this goal state that they're trying to fit.